What if I multiply 1/2 times 4/5? What's my answer?
4/10.
How'd you get that?
I just multiplied the top and then multiplied the bottom.
Okay, good. 1 times 4 is 4. And 2 times 5 is 10. Then it would be 2/5, right? Because we reduce. Because there's a factor of 2 in the 4. Right. Now, at this point, when you got to 6th grade, hopefully they up the game, right?
No, I learned this in 7th
So,
grade.
well, I'm sorry for you. Now, in 6th grade, actually, I think you guys are supposed to start algebra now in 6th grade. But anyway, in 6th grade, back in my age, you would cancel out factors first, right? So you would recognize, hey, 2 is a factor of 4. So before I even multiply, let's see, 4 divided by 2 is 2. 2 divided by 2 is 1. Then you would multiply across. 2 times 1 is 2. 5 times 1 is 5. And you come out with an already simplified answer. Yes, Will.
I remember there being something about like you switch the bottom number and the top number.
It's dividing fractions. Okay? And we're going to get to that. We're going to get to that. All right. So we're going to simplify and some pretty easy monomials, right? Okay. But we're going to do the 6th grade method. We're going to cancel out before we do any kind of multiplication. So we're going to learn how to cancel out first. In the first one, what can I cancel out?
4.
Yeah, the 4. There's a 4 in the numerator and there's a 4 in the denominator.
So would it just be x over 1?
So it would just be x over 1. What about number 2?
You can cancel out one of the x's.
Good. There's nothing I can do with the 3/5. But this is x to the first, x to the second. I can take out one of those x's, and I'm left with x to the first on top. So you know how to do that, okay? Because you did that in Algebra 1 many times. Algebra 2, this is the new stuff. I have the quantity x plus 3 times the quantity x plus 4 times the quantity x minus 4, all divided by the quantity x plus 3 times quantity x minus 3 and times quantity x minus 4 plus 4. It's not too much. It's only six factors. By the way, these are what? What are these quantities called? They're factors. They're factors of a polynomial. It's what you did last night, right? When you factored your quadratics, you got quantities times each other. Okay. Now, so I'm going to look at these and say, hey, I can cancel out whole factors as long as they're the same, right? I can cancel out the x plus 3. Anything else?
No.
I can cancel out the x plus 4s.
Oh, okay.
And I'm left with the quantity x minus 4 divided by the quantity x minus 3. Now, please use the parentheses when you have 2 terms or more. I'll say that again over and over and over again because students have the tendency, hey, I can cancel out the x's, but they're in parentheses. You can't. So whenever you come upon a problem, it doesn't have parentheses, put parentheses there. 2 terms or more. Remember, terms are separated by a plus or minus sign. 2 terms or more, put parentheses around them. Okay, because 4 is a good example of it, what would you have done first? If I didn't put those parentheses there, what's a tendency for students to do?
Factor out the x squared.
Yeah, they would cross out the x squares, right? And my answer would be 5x over 1. You can't do that, okay? When you have 2 terms, you have to factor first. Okay. How can I factor that numerator?
X.
Right, we take out the common term, x. What am I left with?
Plus 5 in parentheses.
Good. Can I factor out the denominator? No, it's in simplest form. Now what? Now that that x to the first is outside my parentheses, I can cancel it out with one of the x's here. So x to the first, x to the second leaves me with x to the first. So my answer here, the quantity, again, use parentheses, x plus 5 over x to the first. Those parentheses help me from crossing out those x's. Don't do that. It's inside the parentheses. Okay. All right, number 5. I have more than two terms, two or more terms. I'm going to put it in parentheses. Same with the denominator. Okay. I need to factor both of these. Factoring out the numerator. I have a trinomial. I don't have any common factors, any common terms. So I'm going to go directly to guess and check. Only one way to get x squared. X times x. Okay, I have a 12. Factors of 12. 1 times 12. 2 times 6. 3 times 4. So they have to multiply to a negative, so one's positive, one's negative, which means we're going to subtract the factors, right? We're going to subtract the 4, so we're going to use 6 and 2. And doesn't matter where I put the 2 and the 6 because our coefficient for x squared is 1. So I'll put the 2 here and the 6 here. Now one's positive, one's negative. I want the larger one to be negative because this is a negative 4. So I have x plus 2 times x minus 6. Now the denominator. I have x squared minus 4. Anybody recognize what type of problem that is?
You just do x plus 2 and then also x minus 2.
Good. It's a difference of squares. Okay. This is x squared minus 2 squared. So the bases are x and 2. X plus 2, x minus 2. Now, can I cancel out any quantities?
X plus 2,
And what am I left with?
x minus 6 over x minus 2.
And I'm going to put them in parentheses so I don't cancel out the x's. How about number 6?
You can factor out 5 off of both sides.
Yeah, we can factor out the 5 and one of the x's. So 10 divided by 5 is 2. 2 x's, 1 x leaves me with an x. 15 divided by 5 is 3, and the x's cancel out. Am I done?
No, you can remove 5x.
Yeah, I can take out the 5, and I can take out one of the x's because they're outside the parentheses now, right? So I'm left with x to the first over the quantity 2x plus 3. Number 9, can I factor the numerator?
Yeah. Factor square.
It's a difference of squares, so it's x plus 3, x minus 3. And I cannot factor the bottom, it's already factored. Can I cancel anything out?
Nope.
So I'm done. And the last one. See, can I factor the numerator?
Yeah.
Okay. Let's see, only one way to get x squared, x times x. Factors of 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. See, it's the same sign. It's a positive, so it's positive times positive or negative times negative, which means they're going to add up. Factors are going to add, and they have to add up to 10. 6 and 4. And they're both, let's see, they add up to a negative number, so they have to both be negative. And that's fun stuff.
Really.
Thank you. Thought it'd make your day. Okay, factor at the bottom. X times x. Factors of 12. 1 and 12. 2 and 6. 3 and 4. It's a negative number, so we're going, one's positive, one's negative, so we're going to be subtracting, and they have to subtract the 4. So 2 and 6. Let's see, we want the larger one to be negative because we want a negative 4. Look at that, we can cancel out. And I'm left with x minus the quantity x minus 4 over the quantity x plus 2. Okay. All right, multiplying monomials. Now you did this again. This is kind of should be review for a lot of you, but let's go ahead and review. Um, Number 9. I like to do now. There's several different ways to do these. Okay, if you have your way of doing it, great. What I like to do is I like to cancel out the numbers. Okay, cancel out the factors and the numbers. So 5 goes into 10 twice, goes into itself once. 2 goes into 6 3 times, goes into itself once. So number wise, I have 1 times 3 is 3. 2 times 1 is 2. Then I like to combine or go ahead and multiply my numerator out with the variables. X squared times x cubed.
X to the 5th.
X to the 5th. Good. We add the exponents. Y to the 1st times y squared.
Y cubed.
And then do the same thing with the denominator. Well, I only have the x to the 1st. Y cubed times y to the 1st. Y to the 4th. Now, you can apply the exponent rule for quotient property, right? But since we've been canceling, we just go ahead and keep canceling. Nothing's going to happen with my 3 over 2. I have x to the 1st, goes into x to the 5th. I have 4 left over, right?
On the top.
Yeah. And y to the 3rd, that means I'm going to have a y to the 1st left over in the denominator. And there you go. Let's do number 10. The first thing you're going to do here for the numbers, I have a 16 on top and an 80. I don't know for sure, but I'm going to go ahead and see if 16 is a factor of 80 just because, these problems have a tendency to be set up that way. I'm going to take 80 divided by 16. And I get 5, so lo and behold, 16 as a factor of 80 goes in there 5 times. So there's my numbers. 1 on top. 5 times 5 is 25. Then I'm going to do my variables across. X cubed times x to the 5th, x to the 8th, and I got a y to the 8th. Denominator, I have an x cubed, y to the 9th, plus 1, y to the 10th. I'm going to go ahead and do my canceling now. See, I got my 25 in the denominator. Don't know if I need that 1 there or not. I'm going to leave it out for now. See, 3x's, 8x's leaves me with 5x's, right? 8y's leaves me with 2y's. And that's it. Questions on multiplying monomials? Want me to do one more? And do number 12. See, 4 goes into 12 3 times. 5 goes into 15 3 times. So I have 3 times 3 is 9. Then 1 times 1 is 1. Then my variables across, x squared times x squared, x to the 4th, y to the 1st. Here I have x to the 1st times x to the 1st, x squared, y to the 1st. So let's see, my y to the 1st cancel out. Got 2 of the 4, so it's x squared. So all I have down here in the denominator is 1. So I didn't even need to put it on 1. It's just 9x squared. If you want to put it over 1, it's certainly not going to take off for it. Part 3. Okay, here we have polynomials times polynomials, right? Now, remember, we're going to cancel out first before we multiply across. Are you ready? Look at your smiling faces and you're all you want to do
So
this.
excited.
I know you are. Try to hold it back. All right. Let's see. I'm going to write it down here. Can I, so I'm looking at the first fraction. Can I factor out the numerator? I can take out a 4x, right? And I'm left with 1 minus x. That's kind of goofy. Huh? And let's see, times. Might as well just stay in the numerators for now. Let's see, need to factor that one. So x times x. See, factors of 6, 1 and 6, 2 and 3. It's a negative, so one's positive, one's negative. They're going to subtract to 1. I'm going to use 3 and 2. And it has to be a positive, so the bigger number gets a positive. Boy, that was fun. All right, denominators. Factor x squared x times x. There's only one way to get 3. That's 1 times 3. And I want 3 to be the bigger one because we want to end up with a positive 2. And then we have 4x. All right, I think I got everything factored. Now we're going to cancel out. See, 4x cancels with the 4x. X plus 3 cancels with the x plus 3. And these two are almost the same, aren't they? Except this one's 1 minus x, this one's x minus 1. I can make this factor look like this by taking out a negative 1. So that's what I'm going to do. I'm going to take out a negative 1, and it switches the sign inside. So I have a positive x minus 1 for my factor. Now I can take this, cancel it out. But I can't forget about that negative 1. Times x minus 2 over, well, everything canceled out here. So I can even simplify this further. Cancel the 1's out, or just put it over as a whole number. Negative x minus 2. Either one of these would be fine. Now you guys are saying, oh, show me more, show me more. This is really cool. Well, you guys look really tired today. All right, number 14. Okay, I'm going to go ahead and factor my trinomials, or all of them, right? If you want, you could actually just kind of use the same problem, but I'm going to rewrite them. Let's see, the numerator for this one, x times x. And we did x minus 6, didn't we? We did this exact one. That was x plus 3, x minus 2. That was easy. Over 2x squared times, see, I can take out a 2. Leaves me with x plus 4. Factor the denominator. X times x. Now factors of 12. 1 times 12. 2 and 6. 3 and 4. It's the same, it's a positive, so it's the same sign. They're going to add up to a positive, so they must be plus times plus. And they're going to add up to 7, so 3 and 4. Aren't you guys glad that you have strong factoring skills?
No.
Uh,
I want
let's cancel out the 2's, right? We can do that because it's outside the parentheses. X plus 3, x plus 3. Ooh. X plus 4, x plus 4. That's as far as we can go, huh? We have an x minus 2 over x squared. I cannot cancel out any more x's because this is in parentheses. Ooh. Ooh. Wow, 15 and 16 are cubes. Should we do a cube? Why, yes, Mr. D, let's do a cube. All right. You guys wanted to do it. Okay, x plus 2 is factored. Can we factor?
factor the power by perfect cubes.
Yeah, these are perfect cubes, right? So my a, this is 3 cubed, x cubed, 2 cubed, right? So my A is 3x. My B is 2. Okay, so I have, this is addition, so sum of cubes. So I have 3x plus 2 times the quantity a squared. A squared. Oh man, this is a long problem. So 3x squared. Don't forget to distribute that too. 3 squared x squared, which is 9x squared. Um, plus, nope, minus. Yep, minus a times b. 3x times 2 is 6x. Plus b squared. 2 squared is 4. And I noticed something here. Now this is over 1, right? These are the same, aren't they? So I'm not going to factor this. Because I can cancel out, now this is over 1, I can go ahead and cancel out these trinomials because they're the same. So I'm left with,
X plus 2 over 3x plus 2.
yep, okay. Last section. Actually, part 4 is just the exact same thing as part 3, except you have to do what? We're dividing fractions.
So
Remember?
flip them.
So yeah, flip the second one. So 5x, and even if you want to, while you're writing it down, you may want to go ahead and factor it. Say I can take out a 3, leaves me with x minus 4. We change the division to multiplication, and then we flip this one. Now I'm going to go ahead and factor that at the same time. Okay? X times x gives me x squared. Factors of 8. See, 1 and 8, 2 and 4. It's the same sign. So I'm going to use a negative negative because they're going to have to add up to a negative. And the factors that add up to a negative, 2 and 4. And then the numerator becomes the denominator. I'm going to go ahead and factor that while I'm rewriting it. Take out an x, and I get an x minus 2. Okay, now I can cancel out some stuff. X minus 2's, x minus 4's, this x with this x. And I'm left with, after all that, 5/3. Let's do one more division problem. It's the last one, right, guys? Number 12. I have a division, so I'm going to change it to multiplication and flip them. Okay, first fraction stays the same. And I'm going to go ahead and factor as I rewrite it. So I can take out common factors of a 5 and an x. And I'm left with 5x squared divided by 5x is just x. 10x divided by 5x is just 2. I'm going to go ahead and factor the denominator. x times x. I'm going to use the factors 3 and 2. They're going to have to subtract to a negative 1, so minus 3 plus 2. Now, I have to flip the second fraction, right? So x squared minus 9 is going to become my numerator, which factors to, it's a difference of squares, right? We did this already. X plus 3, x minus 3. And the numerator becomes my denominator. Looks like I could just factor out common terms. 15x squared. That leaves me with x to the first plus 45x squared divided by 15x squared is 3. Cancel out. X plus 3's, x minus 3's, right? See, 5 goes into 15 3 times, goes into itself once. X to the first, leaves me with x to the first down here. So the only thing I got left, 1 over 3x. Yeah. A lot of stuff. I know it is. You got to do the homework, guys. You got to get to learning this. You got to practice your factoring if you're not good at it. So for your homework, and you have 2 days to do your homework, right? 2 days? 2 days? You could do all the problems. Page 7 and 8, right? Pages 7 and 8. And I won't see you guys until Friday, right?
Yeah.
Right? Yeah. So you could spend all night doing it and all night tomorrow doing it. Isn't that fun?
You like CE? I'm technically a sophomore, so I go in the morning.
Oh, you're going in the morning?